Hi there, Luis is here. Welcome to this hands-on first steps into the zero knowledge world. And today we're going to focus on doing a very short, quick tutorial with snark.js, which is one of the frameworks you can use to work with zero knowledge proofs. So I invite you to watch the video, also to subscribe, share, and visit my blog where you can find hundreds of articles all about software engineering and many other things. So let's jump right in. So in this tutorial, we're going to gain a hands-on experience in building zero knowledge proofs using Circom and snark.js frameworks. So we're going to understand how to create private verifiable computations without exposing the sensitive inputs. We're going to learn how to simplify complex zero knowledge setups with some practical techniques like using pre-generated setup files. And also you develop a foundational skill set to build zero knowledge proofs and applying them to applications. So let's jump into some of the key concepts. Although this tutorial is going to be very hands-on, it's important to keep some concepts in mind. Maybe if you are familiar with, you can skip this part, but I think it's really important that before jumping into the code, you understand what's around it and what are the concepts involved. So some key concepts around zero knowledge proofs are this. So we have the concept of a proof. As for instance, Bob can generate a proof to prove to Alice that he knows a secret, for instance, a password, without telling her the secret itself, right? So the proof is something that Bob can send to Alice and Alice can simply confirm that the proof is valid. That is the concept of witness. So witness is some hidden information that is used to demonstrate the knowledge. The circuit, which is a key component, are the logical steps that are followed to prove his knowledge. So you're gonna focus a lot on circuit, so you can understand it as the logical steps. Then there is the role of the verifier and the prover. So the verifier is the one interested in to check if the proof is valid or not, and the prover is the one who must prove some statement to the verifier, right? So these are the key concepts, and jumping into a bit more of detail about how those pieces come together into ZK knowledge with snark.js and Circom. So as I said before, that is the component of a circuit, which is essentially the logical steps to produce a proof. And in our implementation, we're going to use a language called Circom, which is a specialized programming language for designing circuits. So essentially what we're going to do with circuits is we're going to use Circom to transform those pieces into a code that will be then compiled, and as an output will be the proof. Following up, we have the constraint system. So the constraint system are the rules that will combine inputs and associate them with certain mathematical and cryptographic operations to generate the outputs. So we're gonna see it in practice, but essentially you can think of it as combining variables and inputs, doing some operations with them, and then combining it into an output. There are the role of the witness, as I just said. So in terms of snark.js, we can think of witness as the intermediate steps that are going to take place by consuming the inputs, applying some logic, and then you have the output. So for the purpose of this tutorial, you can understand witnesses as these intermediary steps in the process. And next up is the trusted setup. So as we saw before, that is the role of the prover and the role of the verifier. Prover, which produces the proof, and the verifier will check if it's true or not. And for the prover and the verifier to communicate with each other over a secure channel, you need to perform a trusted setup, essentially generating keys. And that's what we're going to do also in practice. And moving on, we have finally the proof. So all those previous steps will end up generating a JSON file, which is the proof itself, which can be consumed and verified. Moving on next, we have all those pieces together. So that's what we're going to do in our tutorial today. We're going to design a circuit using Circom. Then we will compile the circuit to get the constraint system. Also have it, we use snark.js to compute the witnesses, which are the intermediary values. Once we get the witnesses, we're going to generate the trusted setup between prover and verifier, which are going to generate the keys. And finally, we get to validate the proof. So these are the steps we're going to perform in our tutorial today. And yeah, so now let's jump to the hands-on part of it. To get started, we need to have the environment set up. There are some tools we need to install. So make sure that we install Node.js. It's pretty simple to do this. We're going to use Circom as the programming language, and Circom requires Rust to be built. So we need to install Rust compiler, and after that we can compile and install Circom. And lately we can install snark.js, which is one of the NPM packages. So let's go over it. If you have already set up this environment, or if you are familiar with how to install them, you can skip this part. If not, let's jump into the step-by-step. So installing Rust, which may take a bit more of time, but it's essentially simple. You're gonna run this Rust setup using Rust app, which is a tool for installing the environment. So you can use, if you're on Linux, you can download this and install, and follow the on-string instructions to complete the installation. Once it's installed, you're gonna configure it to make sure you're using the stable version, and finally check if the Rust environment is properly installed, running Rust C version, right? So if you, at the end of the installation, you see the version number of Rust, it means your Rust environment is ready to be used, and you can go to the next step, which is to install Circom. So you need first to clone this repo, which is the Circom repository. Then we're gonna compile it using cargo from Rust. Once you have the executable, you're gonna export it to your path, and you're gonna confirm the installation was successful by running Circom version on the command line. If you see the Circom version, it means installation was successful. Next up is Node.js and snark.js. So there are no secrets here. You can go to Node.js official repo and install it. And you can install snark.js using npm package manager. Once we have all those tools in place, we're going to create this following project structure. So we're going to create a ZK some product project with 3 subfolders on it. And yeah, that's all about the environment setup. Let's jump to Visual Studio now and start coding. So now here on VS Code, let's start coding. And the first step is to create our circuit. So we're gonna go here under the circuit folder, and let's create a file. Let's call it some product .circom, which is the extension for Circom programming language. We're going to start at the top defining the pragma version. So we're going to use Circom version 2.0.0 or anything above it if you are watching it later on. And we're going to define a template. So our circuits are defined under a template. You can have one or more templates, and as the name say, templates can be reused and can be composed. In our case, it's going to be a very simple one, so we're going to implement it ourselves. It's going to be some product, let's name it. Then we're going to have the inputs and outputs, which in Circom are defined using the signal keyword. So for our secret, we're going to have two inputs, input A and input B, which we're going to use to make the computations. As output, we're going to have also two outputs. We're going to have a sum and we're going to have a product. So let's define this output here as well. So inputs for the circuit, outputs for the circuit, and now comes the constraint. So the constraint, remembering, are the operations that we're going to perform over our inputs to generate the outputs. Are those logical steps that are going to be taken. So we're going to assign to some the result of A plus B constraint, and to product, we are going to assign the result of A times B constraint, right? So the constraints are those operations you're going to perform with these inputs here in order to generate these outputs here. And to finish the circuit implementation, I'm going to export it as a component. And that's pretty much all we need to do in terms of writing the circuit. So the idea of the circuit is to represent a computation, right? So in this case, in our case, we are going to represent the sum and the product of two inputs, and the verifier. Once you compile this circuit, the output will confirm that the computation, that this sum and the product were done correctly. We're gonna see how it happens next. So also have this circuit file. We're gonna save it, and the next step is to compile the circuit, and you do so by running Circom and passing as parameter this created Circom circuit file. We pass as parameters also the type of constraint system we're going to use. In our case, we're going to use rank 1 constraint systems. We don't need to worry that much about it now, but it's important to understand what those parameters are. Our output will be generated in WebAssembly, and we're going also to generate a single output file, which you can use later on for debugging. And finally, the output folder, which is this output here. So let's compile this circuit. It's done. Once it's done, we can see some detailed information here. So we had compiled one template instance. There is one nonlinear constraint, one linear constraint, two private inputs and two public outputs. There are 5 wires, so the way those 4 signals are connected together are through wires. And then as output, we have 3 files, the rank 1 constraint system, which you can have a quick look here. It's a binary file. There's not much you can see, but let's just have a look on it to confirm it was generated. Also, the symbol files for debugging, and the heavy logic, let's say, in this WebAssembly file, which is right here. So there is a lot of computation going behind the scenes that we can investigate later. But for now, uh, these are the if you have a bit more of experience using assembly or some sort of low-level programming, you can see here some sort of opcode or low-level instructions like those. If you are curious, you can explore it further. But for now, that's fine. All we need are to generate those output files as we compile the circuit. So once the circuit is compiled, very next step is to move to generate the keys, and the first step is we're going to use a simplified key generation process, so we can use these already existent um, powers of tau file. So I won't enter into details about this file because it's a bit more complex. And for now, we can use this pre-generated version here required for the keys. Once we have it, we will effectively generate the keys, and we do remembering that the keys are used by the verifier and the prover to connect and make the verification within a encrypted environment. So to generate it, we need to run this snark.js instruction. We're going to use the setup algorithm, which is graph 16 in our case, and we're going to ask it to set up our keys using the Rankin constraint and the powers of tau pre-generated file we've seen before. So keys generated here. Now next step is to export those keys so they can be used. Let's go here now. Next step, we're going to export these verification keys, and we can see they were exported. And once we have those keys, we're going to take care of the input. So if you remember here, we have two inputs, right? A and B, and the circuit itself will receive those inputs and generate the output. So we need somewhere to do this circuit the values of those inputs, and we do so by going by creating a input JSON file. So we're gonna go here under input folder. We're gonna create an input JSON file here, and in this JSON we're going to inform here that we're gonna have A as input. Let's say it's 3, and parameter B is gonna be 4, and that's it. So those are the inputs we're gonna use. So you can change them whatever we want, and the circuit will remain the same. We don't need to recompile the circuit, right? So once this file is saved, we can move to generate the witness. So remembering the witness are the intermediary steps. So in this case, we're gonna have those two inputs. We're gonna do a sum and a product operations, and when you run them, our circuit needs to store two witnesses, the result of the sum, the result of the product, and then they will be combined, right? So we're now in this step in which we generate those witnesses, and we do so by calling this node script, which will take our WebAssembly file that we have generated before, and we'll generate the witness. So we run this, and if you go to the output file, you're gonna see there is a witness file now. Again, binary file, you will not be able to see much, but out of curiosity, it's important to know what's going on behind the scenes. Okay, so we have now the witnesses generated. Very next step is to actually generate the proof, which is the last step in terms of proof generation, and we do so by calling this graph 16 using snark.js, invoking the proof method, which will generate the proof. Now, if you go to the outputs, there will be a proof file, which is this, essentially the math behind the computation we're encoded here into those variables. And yeah, so now let's use the proof that I have generated, which we do so by running this verifier. So usually what you do is that we generate the proof and we send it over to the verifier, right? We're not going to generate and verify the proof ourselves, but we can do this now to check and ensure that our generated proof is valid. So you do so by running this verify script, and it all goes right. I'm gonna go this OK here, which means the generated proof is valid, right? So that's essentially the steps that I need to take to generate zero knowledge proofs using snark.js and using Node.js. Yeah, and you made it. Let's have a wrap up so we see everything that I have done so far. So congratulations for finishing this. There was a lot of things that we did. It might seem confusing at first because there are many outputs generated. We're gonna see here what are they used for. And our secret is a very basic one, just a sum and the product of two variables. And when you look at the code and when you look at the steps that I have taken, it might seem like it's a huge effort for a little benefit. But keep in mind that in real world scenarios, we're going to have massive computations being done in lots and lots of steps with very complex circuits. So we don't need to generate all those steps every time we're going to run a verification or generate a proof, right? So some of those steps will be done once and you will reuse your secret later. But the thing is, working with zero knowledge proofs requires those key concepts that we have seen at the beginning. That's why it's important to keep those steps in mind. And yeah, this is the wrap up. So essentially here we have a list of the outputs and we have seen the rank 1 constraint system file and it defines the constraint that must be satisfied in the circuit. All those files were generated by snark.js, right? So we only provided snark.js with the public inputs, which were the two numbers we're going to sum and get the product, and the circuit design, right? So we have the circuit design in the inputs. That's all you need to generate the proof, right? Those other files here are intermediary steps in the process. So at the end of the day, you design your secret, you generate the proof and send it over, and the verifier will take this file and run the verification, right? So using it, it's not that much complex. So yeah, that's it. That's our wrap up. Yeah, so I would like to thank you for following along with this tutorial. It was a very basic first steps, as I said, but I hope it gave you a taste of what is it like to work with zero knowledge proofs. Again, this is just one of the ways you can work. We're using Circom. There are much more advanced tools, frameworks, and ways of working. But if you have to start from scratch, I would start with Circom so you can use this tutorial to get started as well. And I invite you to visit my blog. There are more than 200 articles. There are all sorts of things. There are articles about Rust, about blockchain, implementing zero knowledge proofs, and many other aspects of software engineering. There are explainer videos about many topics. There is a brand new weekly podcast where you can also, get informed and get some tips on software development. There are also my books. I have written a book, two books, one about Rust and the other about cybersecurity development. And also there are some hands-on tutorials with GitHub. There is a API gateway, there is a firewall, there is a blockchain totally implemented from scratch where you can see the code and you can also, yeah, get a taste of it. So I hope you have enjoyed this video and I invite you again to follow me on social media, visit my blog, and yeah, like, share, and yeah, see you on the next video. Thank you.